Welcome to the Explainer. Today, we're cracking open the control box to see how the automated world actually works. From the traffic lights you see every day to the factories that build, well, everything, there's this unsung hero making it all happen.
Yeah, really. Have you ever thought about it? What is actually telling that giant factory robot arm exactly where to move? Or what's the secret behind making sure a roller coaster is perfectly safe, run after run? It's definitely not magic, and the answer is something pretty amazing.
And here it is, the Programmable Logic Controller, or what everyone calls a PLC. Now, don't picture your laptop. This thing is a different beast altogether. A PLC is a super tough, rugged little computer built to survive the heat, the dust, the vibrations, all the chaos of a factory floor.
So what's actually inside one of these hardened boxes? Let's go ahead and crack it open to see what makes it tick.
Okay, so a PLC is basically a team of 4 crucial components all working in perfect harmony. You've got the processor, the I/O modules, a power supply, and a programming device. Let's get to know the team.
First up, we have the processor. This is the command center. It is, for all intents and purposes, the brain of the whole operation. It runs the program and makes all the critical decisions for whatever machine it's hooked up to.
Next, you have the input and output modules, or I/O for short. Now, I want you to think of these as the PLC's senses and its muscles. The input modules, they're like its eyes and ears, reading signals from sensors and buttons. And the output modules, they're the muscles, sending out commands to make motors spin, lights turn on, and valves open.
And of course, just like any brain, it needs energy to function. The power supply is the heart of the PLC. It pumps a steady, clean voltage that keeps all those super important electronics running just right.
So finally, how does the PLC know what it's supposed to be doing? Well, that's where the programming device comes in. This is usually a laptop where an engineer writes the code, the actual instructions, and then just uploads it right into the PLC's memory.
Okay, so we've got all the parts down, but how do they all work together? How does a PLC actually, think? Turns out it speaks a very specific and surprisingly visual language.
Most of the time, PLCs are programmed using something called ladder logic. And the reason it's so popular is because it's a graphical language. It was actually designed to look just like the old-school electrical diagrams it replaced, which makes it super intuitive for technicians and electricians to pick up.
And you can see why it's called ladder logic. Each horizontal line is a rung on the ladder, and each rung represents one single rule. The idea is simple. If you can trace a path for electricity to flow from that left rail all the way to the right, then the rule is true and the PLC takes action.
Now, by stacking hundreds or even thousands of these simple little rungs, a PLC can manage some incredibly complex stuff. But it all boils down to just a few fundamental rules of logic.
At its heart, everything a PLC does is based on simple if-then statements. So let's start with the most basic building block, the AND gate. Okay, check out this ladder diagram for an AND gate. See how the 2 input switches are in a series? They're one after the other. This means for that power to flow from left to right and turn on the output Q2, the first switch and the second switch have to be closed. Both of them, no exceptions.
And we can map this logic out in what's called a truth table. Just think of 0 as off and 1 as on. As you can see right here, the only way to get a 1 at the output is if input A and input B are both 1. Pretty straightforward, right?
All right, now let's look at a different rule. This is the OR gate. Notice the big change here? The inputs are now wired in parallel, not in a series. This one tiny change gives the PLC a whole lot more flexibility.
And you can see that flexibility right in its truth table. This is a totally different behavior. Now, if input A is on, or if input B is on, the output turns on. The only way for it to be off is if both of the inputs are off. It's a completely different way of making a decision.
Okay, this is all fascinating stuff, but it really begs the big question. Why PLCs? I mean, before these came along, factories used these massive, complex walls of clicking electrical relays. So why did this little box completely change the entire game? Well, it really just comes down to this. Compared to those old relay systems, PLCs are incredibly reliable. They use way less physical wiring, they operate much faster, and here's the best part, if you need to change the logic, you don't have to rewire a single thing. You just upload a new program.
That's it.
So, when you combine thousands of these simple rules, these little ands and ors, a single PLC can control just about any automated process you can think of. They really are the invisible workhorses that keep our entire world moving.
So, the next time you go through an automatic car wash, or you ride an elevator, or even just see a traffic light change, you'll know the secret. You'll know that there's a simple, powerful PLC in there, quietly and reliably running the world around you. And once you start looking, you'll see their logic absolutely everywhere.